A forest is not just trees. An economy is not just money. A body is not just organs. For centuries, humanity tried to understand the world by breaking it apart. Analyze the pieces, isolate the parts, simplify the whole. And often that approach worked. But eventually, something became clear. Some problems refused to be solved in isolation. Climate change, financial crises, epidemics, organizational collapse. The world is not a collection of separate parts. It is a network of systems. The concept of systems thinking transformed how scientists, engineers, policymakers, and leaders approach complexity. It changed problem-solving itself by asking a different question. Not what is this made of, but how does this interact? The roots of systems thinking stretch back centuries, but it emerged formally in the 20th century. Traditional scientific method relied on reductionism, the idea that understanding individual components would reveal the behavior of the whole. This method fueled breakthroughs in physics, chemistry, and biology. Yet as societies grew more interconnected, reductionism revealed its limits. In the 1940s, biologist Ludwig von Bertalanffy introduced general systems theory. He proposed that living organisms could not be fully understood by analyzing their parts independently. Instead, organisms function as integrated wholes, systems whose properties emerge from relationships between components. This marked a shift. The focus moved from isolated elements to interactions. In parallel, cybernetics explored feedback loops, circular processes where outputs influence future inputs. Engineers studying control systems discovered that stability and instability arise not from single causes, but from patterns of feedback. A thermostat regulates temperature not by force, but by responding to its own effect. These ideas soon extended beyond biology and engineering. Economists began modeling markets as dynamic systems. Ecologists viewed ecosystems as networks of interdependent species. Urban planners recognized cities as living systems shaped by infrastructure, policy, and human behavior. Systems thinking introduced several key insights. First, systems contain feedback loops. Some stabilize, others amplify change. Second, systems exhibit nonlinearity. Small inputs can produce disproportionately large outcomes. Third, systems generate emergent behavior, patterns that cannot be predicted solely from individual parts. Consider traffic congestion. No single driver intends to create a traffic jam, yet collective interactions produce gridlock. The system generates behavior independent of individual intention. Similarly, in global finance, localized decisions can cascade into systemic crises. In epidemiology, minor policy delays can alter infection curves dramatically. These outcomes reflect structure, not randomness. Systems thinking also changed how solutions are designed. Traditional problem-solving often targets symptoms. Systems thinking asks about root structures. Why does a pattern persist? What incentives or feedback loops sustain it? In public health, for example, addressing disease requires examining education, income distribution, urban design, and cultural behavior. In environmental policy, carbon emissions cannot be separated from energy systems, transportation networks, and economic incentives. The strength of systems thinking lies in recognizing interdependence. However, it also demands intellectual humility. Complex systems are difficult to predict precisely. Interventions may produce unintended consequences. History offers examples. Agricultural policies designed to increase yield sometimes destabilized ecosystems. Economic stimulus programs occasionally inflated asset bubbles. Well-intentioned reforms can amplify the very problems they aim to solve if systemic interactions are misunderstood. This does not invalidate systems thinking. It reinforces its importance. Modern computational modeling has advanced the field. Simulation tools allow researchers to map interactions across variables and test scenarios before implementation. Climate models integrate atmospheric physics, ocean currents, industrial emissions, and biological cycles. These models do not offer certainty, but they provide structured insight. In organizational leadership, systems thinking transformed management theory. Companies are not hierarchies of tasks alone. They are adaptive systems of culture, incentives, communication, and feedback. Sustainable performance depends on alignment across these structures. Education has also adopted systemic approaches. Learning outcomes depend not only on curriculum but on social context, psychological safety, nutrition, and community engagement. Even neuroscience reflects systemic logic. The brain functions not as isolated modules, but as networks of dynamic interaction. Consciousness itself appears to emerge from complex systemic integration. Yet systems thinking carries limitations. Models simplify reality. Variables must be selected, boundaries defined. No system can capture everything. Complete prediction remains impossible in highly complex networks. What is known is this: interconnected systems shape outcomes more than isolated events. What remains uncertain is the extent to which human design systems can be controlled without producing instability. The concept challenges a fundamental cognitive habit. Humans prefer linear cause and effect. We seek single explanations. Systems thinking asks us to accept distributed causality, where multiple factors interact simultaneously. This perspective reshapes responsibility. It suggests that lasting change requires structural redesign rather than isolated intervention. Seeing the world as interconnected systems changes how problems are framed. It replaces blame with structure. It replaces reaction with analysis. It replaces isolation with relationship. The forest is not only trees. The economy is not only transactions. Human society is not only individuals. Systems thinking does not simplify the world. It reveals its complexity. And in that complexity lies the possibility of wiser decisions. If this exploration expanded your understanding of how the world truly operates, consider liking this video and subscribing to Interesting MindHub for future documentaries that challenge how we think. Because understanding systems is not just an academic exercise. It is a new way of seeing reality itself.